Hello, everyone. Welcome to Preface Nomad Junior. This will be a live review session on the projects that we've done this past week. And hopefully you guys enjoyed it. I think there are a few projects there with varying levels of difficulty. Some of them are easy, some are easier, some of them are harder. Yep. So, so to start off with, so we'll just go through the few projects that we've done this week, all right? And so remember on Monday, we had uploaded this underwater adventure. So remember, this was a variation of the space adventure that was previously done. And shout out once again to Alvin for helping with the recording. So over here in the underwater adventure, what we began with was that we learned about some conditions called if then, which we'll go through in a bit later. And remember, if you remember the game correctly, it is of a diver trying to get to his rocket ship, right? So he tries to go lower or higher accordingly. If he touches the octopus and sharks, he will end up back in his original position. And if he goes to the rocket ship, he will end up being able to leave. So a congratulations sign appears, and practically you've won the game, right? So that was the first thing we done this week. The second thing we done was produced by Miss Athena and Miss Carmen. So remember, there was a project that we actually kind of made it with alongside in the name of like Flappy Bird. So not exactly the same thing, but as you can see, it's of a bird. It has a moving background, and what we can do is that we can move it. So we can move it up, down, left, right. You can see the wings flap. And as it catches the stars, the points will go up. So the two main focuses for this lesson this week for catching the star or the flying game is, first of all, how to make a moving background. So if you remember, the bird doesn't move at all. So the bird can be placed in the same position on the screen. So if you can see it position-wise on the screen, it doesn't move. But it looks like it's moving because there's a moving background behind it. And it's made by different costumes, made by different sprites. And they keep continuously rolling from the right-hand side to the left-hand side, right? So, and also we learned about the score function. So the score function here talked about how we can increase the score, how we can track a score, right? And we'll talk through that a bit shortly too. Remember, it uses something here called variables. Hopefully you remember these words. They should ring a bell right now if you've been watching our YouTube channel very closely. And the last game we've done, so the final part of this will be uploaded. The final part of this will be uploaded shortly, and that would be the shooter game. So in a sec, you will see it uploaded onto YouTube, and do check it out. So right now, only half of it is complete, but we'll go through the full version of it too in this review session. So the shooter game is a fun interactive process where you see a character that appears in random positions, and I have to shoot it. So I have to hit it, and the score will also increase in the same way. And supposedly a sound will appear, right? So the sound of a drum will appear when I hit this. And once I get to 10 or more, so once I hit it by 10, it will explode. So there will be a change in costume, it will explode, and then it will stop completely. So in this game, we learn a bit about how to upload different sprites. So remember, the sprites, they're different from the previous projects. We can't find them in Scratch, and we use different methods to be able to get them. And furthermore, we learn about these green blocks called operator blocks. And what they do is that they control how numbers work in the system of codes. So how to control numbers and how to compare them within our codes. And the final thing we did was that we learned about the sound blocks, so which is how the explosion sound and how the drum was added into our project. All right, so for this 5 minutes, hopefully you have an idea of what we're going through today. So I know we went through a lot this past week with different types of learning outcomes and different type of knowledge points, but today's focus will be solely more on, so we'll go through every single one of these knowledge points, but it's key to know that we'll be going through most of it will be on the if then and of variables, because they're actually two very important types of coding concepts that you will need to understand as you progress as a coder into our Scratch curriculum. And you'll be seeing them used a lot constantly. And even when you finish, when you're done with Scratch, for example, you've done all you can with Scratch and you want to move on to a new coding language, for example, like App Inventor, or even some harder ones, so some text-based ones like Ruby or Java or Python or JavaScript, having the knowledge of variables and if then helps a long way to go as you journey into these programs. So without further ado, let's begin. And we'll start off with explaining the underwater adventures. So this was the only game this week in which we completely finished in one YouTube series. And the reason why is because this game is more or less relatively more simple, less codes are required, and the codes are, they're not that hard. And remember, I gave you the challenge in the YouTube video is that I told you guys to try and make a variation of it. So in 1 week, I guess you guys have started knowing more about interface, about how to drag different types of code. It's kind of time where you start learning how to, make variations to your sprites too. So you have to completely follow my projects. You can make any changes you like as long as they work and the behavior is similar. It's completely fine. So we'll begin with looking at the project. So right now you can see that I've clicked inside of it and you can see how the project works, right? So you guys should know the game works already. You've seen me fail this level a few times already. And yeah, hopefully you guys have made your own variations and enjoyed it too. So today specifically, I'd like to talk about if then, okay? So I'm just gonna do a very quick roundup of the rocket ship, the shark, and the octopus. So as you can see, they're all just gliding in different speeds, and they go up and down. And different things should happen to them when the diver touches each of them, right? And that is the main focus, remember. Different things happen. So when the diver touches any different sprite, it's not that the same thing happens, rather different things happen all the time, right? So if I hit the octopus, it should be different from when I hit the rocket ship. And remember the utilization, how we did this was through something called if then, okay? So if then, I'm just going to drag this block out for your reference. Remember, it's in controls. So if then is a conditional, and so explanation of what conditionals is that they control in what way in what way do the if then do the conditions work. So it's specific. So first of all, with conditionals, we see a condition. We just figure out whether it's true or not, and then we can make different actions happen accordingly. And this is why if then is the most fundamental conditional coding concept you have, because it is the basis of what conditionals are. Because what you do here is that you have a conditional, right? So in our project, the condition is touching another sprite, all right? So if it touches the octopus, it will go to the bottom. Sorry, so we're having a bit of technical issues on the volume. We'll be back a bit shortly where I'll continue talking about the if then. All right, there seems to be a fix right now, so we're going to continue onwards with our project. Okay, so apologies for that. For those who missed the previous muted parts, I believe we were going into the underwater adventure where we're talking about how the if then works, right? And we were explaining also about why if then is so important. So if then belongs to, remember it belongs to a specific group of codes called conditionals, and conditionals define what actions should happen in specific conditions, right? So if then is the basis of this. So if then, I believe, is hard for some people to abstractly explain, or and understand. And I think a good way of this is to really just put it back into real life, so a lot of things that you can do in codes you can also apply to real life. And yeah, that's one of the great things about coding education. But if then in this sense is that you can imagine, you can put it into almost any single concept in real life. For example, let's just say you're crossing a road, right? So before you cross the road, what's the first thing you do? You have to figure out whether the light is red or green. So if the light is red, remember, if the light is red, what do we do first? We stop, right? So if the light is red, we see what the condition is. If the light is red, we stop. And if the light is green, then we can walk. And the same thing happens if your dad and mom drive. So if you're in the car and see your dad and mom drive, if the light is red, hopefully they're stopping. If it's green, then they go. And if it's the yellow light, hopefully they're slowing down or getting ready to, start. So if then, there's a lot more applications to this. So this basically, it's linking an action to a specific condition. So you can put it in almost everything. Like if you did well on an academic test, if you did well on your latest math test, hopefully then your dad or mom would give you a reward. That could work too. Or yeah. So the basis is that if there's any coding concept you never really understand, there's a very good chance that they can be applied into the real world too. And this is something this is a way that we can understand this as we progress through different types of coding concepts and structures. So if then, right back here, so remember, if then, the key condition separating is actually when to switch the backdrop to underwater 2, which, if you guys remember, is the congratulation part. So it deduces whether we should switch it to this backdrop here, or whether we should make it go back to original position. And the key thing here, remember, is that it's defined by whether it touches what sort of sprite. So if it touches the two animals in between, then it will go backwards. But if it touches the rocket, it will go to congratulations sign, right? So over here is what the if then does. It separates what should happen in different conditions. If it touches the octopus, go back to original position. If it touches the shark, go back to original position. And if it touches rocket ship, then we go to our winning condition, right? So you can see how if then works here. So even though all these codes are within diver, so it's the diver that's seeing what it's touching, but it's not generalizing, because it's not saying that for every single thing we touch, we make it go back to original position. Rather, it's separating what should happen when each different sprite is touched. And I'm also just going to do a few more codes here. So hopefully throughout the past 5 days, you learn more and more about how to work on different types of Scratch sprites. And we're going to continue onwards. We can make this just to remember. So remember we talked about the sound blocks, right? So for example, sound blocks right here, you can add one too. So for example, you can say if it touches the rocket ship, right? To make it more interactive, you just don't want it to be just the pure, congratulations. So what you can do is that hypothetically, what you can do is that you can make it so that you can play a sound. So you can add the sound here. I've got a sound added here called goal cheer. So what it does is that it plays the exact same sound as when I cheer, as when a goal was scored and the cheers happen. So I can literally put this sound into the part where it says it touching rocket ship. So not only will it change the backdrop when it touches the rocket ship, it will also play a celebratory sound. That's one of the variations you can make. A second one is that you can remember there in Scratch when you download, if you guys were aware, there are tons of costumes here you can play with. So what you could do is that you can just make it so that when the green flag is clicked, you can use a forever block and you can make it constantly change costume. And now you have some interactive sprites. So it's not just really just one sprite with one motion, rather it's a sprite that is constantly changing costume to look more like an actual cartoon or animation, right? All right, so let's just complete this and let's just see an effect. Awesome, so now our octopus has a bit more costumes to play with and the whole thing looks a bit more fun, right? Let's just save this and let's move on to our second project. So hopefully you know how if-then works and hopefully you understood the importance of if-then and where you could use it in different types of projects. We're gonna move on and we're going to see the Catch the Star flying game here. So 3 things we learned about in this project. The first thing, well, I'm just going to close this down. So these are just some different codes here and what they do. So first of all, within the sprites, what we can do is that what we see a moving backdrop as explained earlier. Now, if we look at backdrop, it's not really the backdrop that's really moving, rather it's sprites behind the parrot that make sure that this moving backdrop is created. So everything apart from the parrot from the right to the left, so almost giving the impression that the parrot is flying from the left to the right. Yes? Okay, so we can see how this is done. So first of all, let's look at the use of something called motion blocks. So this is something that we've used a lot in our previous projects, but here I want to explain in a bit of a full picture. So we see here and we see that the bunch, so what motion blocks basically do is that they control the way in which a sprite should move, right? And remember, we can do this by setting it into different conditions using the control block. But essentially, the motion block sets how the sprite should move. And so the key difference here, so if you guys remember, is the difference between setting a sprite to a position or making it glide to a position. So when you set a position, for example, when you set the X here or when you make it go to somewhere, what you do is that you move the sprite instantaneously to that specific position. So here, if I make it go to 0, 0 and I click it, this whole building will head up to 0, 0, just like this. All right. Now, rather, if I make it glide, I'm just going to drag to run position. If I make it glide, you will actually see its movement. Oops. You will actually see its movement. So you can see it move its way upwards. All right. So this is these are the 2 most common blocks used to move different sprites around. And this is the way in which they differ. You also used a lot of blocks recently, like go to position, go to mouse pointer, change X, change Y. So these are all, so you can see these are all methods in which you change the way that basically the sprites move. All right. And one more thing here is that you can also set the X position and Y positions here. And so if you remember for the clouds and star here, because we weren't sure what the Y position was, right? Because remember, we're setting the Y to a random number. So it changes every time we do it, right? So hopefully whoa, why's my building all the way up? All right, so hopefully it comes down a bit and the next round it'll be better. Okay, so the cloud here, so you can see what it does is that since we don't know what its Y position is yet, right? So what we can do is that we can just specifically just call out the Y position. So we can completely get this number here, because this number would change every time it moves, right? So that's what we did with the Y position. I'm going to talk about the forever block. Doesn't need much introduction, but it's one of our key areas where we learned about. Forever block, practically, it just makes the code happen and run forever. Simple enough, but I'm going to show you why it's important in Scratch. So I'm just going, for this example, I'm going to go back to my underwater adventure, but stay with me. So I'm gonna go back to my diver. Now what you see here is that you can see the if-then conditions. They're practically wrapped inside a forever block. There's a reason why we do this. If we just left it without the forever block, we won't be able to go back to we won't be able to go back to its original position. So I'm just gonna click the octopus here. So you see, I'm touching the octopus, but right now nothing is happening. I'm not going back to original position. The reason why it's because it's because the code here, what it does is that it's reading the code from the top up. So it's thinking, okay, so I'm making it go to, when the green flag click, I make it go to this position and I have to track. So I'm just gonna remove this also. So what it does here is that it only tracks when we click the green flag and it's touching the octopus. So only at the time so it only tracks the time when I click the green flag to see whether it's touching the octopus or not. Now this is not one, right? Because we want to click the green flag and we want to play. But when we play by moving the arrow keys, it'll go like, whoa, this is not the same event. This event won't be when the green flag is clicked. So what we have to do is that we'll have to get the forever block. So this means that once the green flag is clicked, no matter the condition, as long as my diver touches the octopus or touches any other sprite, it must run these conditions. So you can see the importance of having a forever block inside when you use it with the if-then blocks, because they make a condition happen forever instead of just in that instance. Okay, so this is just a little more deeper explanation of forever block and why it's so important in Scratch. I'm just going to fix this and let's continue into Catch the Star. So the last thing here, so we learned about forever blocks. So the usage here was to make the buildings go forever to the left as well as the cloud and stars. Now, I'm just going to look at one final thing we learned, and that is how to set the score system. So my score system practically is done using blocks called variables, okay? I'm just going to try and see if I can scroll over there. That's good. Okay, so the score system is made out of blocks called variable blocks. And I think this has been the hardest, this is the hardest key knowledge point that we've been talking about this past week. So specifically what variables are is that they're temporary storages. And what I mean by that is that they enable, you can store information, like specific information inside this variable. So you can imagine it as like a drawer, right? You can store this data in. Now, apart from this, you can also do different things with this number. So this number here is a variable because I'm literally storing the number of points I have, right? And so it's not just a storage. What it can do is that it can also be created. So I can also make a new variable all the time. I can read it so I can see how much I have currently. I can update it. So for example, with the points here, originally it is 0. And when I get 1 point, the point increases by 1. So this is updating it, and finally I can delete it. So if I made a variable here called just maybe like live, for example, and then I go like, I don't really need it, then I can just delete it. And delete the points variable, yes. Oh, not the points. I should delete the life. There we go. And so over here, so you can see the way that variables work. And it is a very abstract concept because you're imagining there's literally a real storage that you have here. And the way that we can commonly explain it is that you can imagine it to be like a piggy bank. So one thing I forgot to mention is that for variables, it can only hold one value at a time. So it can't hold like 2 specific values. So in the same way how my score can't be like 1 and 15 at the same time. It can only hold one value, right? So you can imagine a temporary, so to be like a piggy bank, for example. Like so for kids who have a piggy bank, you know that you can continuously add money onto it. And if you want to buy something, you can get the money from the piggy bank. So you remove money from the piggy bank too, right? So you created this variable, you can call it a piggy bank. So you can create this storage. You can read it constantly by counting how much money you have in that piggy bank. And then you can also update it by adding money or taking money away from it, right? And when you're old enough and you can get a bank account, you don't need a piggy bank. So you can just completely, throw it away, delete the piggy bank, right? So this is a way that variables work. And you can see it apply in many different part of games. For example, point system. So like what we have here, the point system, it works like this. So it's exactly how a variable works. It can be created, it can be read, it can be updated and deleted. And in the same way, you can do it for life too, which is also a variation we'll make right now. So over here, as well as making the points up here, we can also make it so that if the same thing happens to clouds. So maybe I could say I could decrease the parrot life first, or I could decrease the points when it touches the cloud. So over here, I can put the same codes here. So I can say that if my parrot, so I'm just going to get my blocks here. And so I'll delete this set points part because I don't need it on the show. But I can say here that when my parrot touches the clouds, I'm not just gonna hide and show, but rather I'm just going to decrease my points by 1. So it works in the exact same way too. So my clouds won't necessarily, so the cloud can make my parrot decrease the score, as you can see. So I added points here, but if I touch the cloud, my score decreases. See, that's a variation you can make too, right? So variables and if then essentially have been the key focuses, and hopefully you have a better understanding of them. So variables, you can really describe them as little storages and devices. So just storages here that are temporary and that you can keep constantly adding value or decreasing value to it, updating what's inside of it. So you can literally imagine like a drawer, like a piggy bank, anything that you can store items in. But remember, you can only store one value at one single time, right? So this leads us to the final game today. So which is our shooter game. And for the shooter game right now, we have the final one for the project for today is being uploaded right now. And so you can see it in full effect. So as Ms. Athena kindly taught us yesterday, there are ways in which you can upload a backdrop, for example. So what you can do is that, so remember our enemy and our target here, they're not necessarily, they're not necessarily in the Scratch library. You can't find them, right? So this how if you remember all the way back to the Pokemon GIFs is how we got the Pokemon GIFs too. So in this way, this is how we can create our different sprites so you don't necessarily need to get the sprites from scratch, right? So for my enemy here, I got it purely, remember, where we actually promised you that we would teach you how to create or upload different sprites, and we've successfully done that. So now you should be able to know how to choose a backdrop, how to paint one, how to, give an element of surprise, and finally how to upload one. So the specific focus for today would be the upload. So all you do is that you upload it straight from whatever. So for example, I want to upload the sprite. I just click on this PNG and I can make it appear. Yep, makes sense, right? So so remember, there are also different techniques Athena has taught you how to do. So for example, maybe if you have a Windows computer and you don't have the preview part, you might have to do it from scratch. So you have to remove the backdrop, any background you don't want from scratch. And if you do, then good job. You can use the pen to help you with that. Okay, so this actually brings us to the project that we have learned today. And actually, so for those, we'll just give a sneak preview of what we've done. So we learned about how to how we were able to define when something happens. So remember, we could compare numbers through the operator blocks. So right now, I want there to be an explosion by the time my score reaches 10, right? So if my score, as long as it's bigger than 9, then it will explode. And the reason why we made it bigger than 9, not just equal to 10, is because sometimes there are some computers which might not detect clicks very well. So it might instantly go from 9 to 12 without ever skipping to 10. So conditions like this have happened before. It's happening less now because Scratch is constantly upgrading to make sure that even in these cases, the score can still run continuously upwards. So if I say change scores by 1 here, it won't just automatically jump from 9 to 13. It will actually still go from 9 to 10, 11, 12, and then 13. So these are just things that you can play around with. And we did a bit more explanation about the operators block with the use of pick random. So this is a way in which we can make this enemy character here constantly appear within the screen. So you won't see one where only half of it appears. Okay, and so operators block and sounds block wise, they're relatively they're not similar, but they're relatively simple rather. So it's up for you to explore it. The operator blocks are a bit more complicated because they require a bit more mathematical knowledge. But if we just look through it, you can see that there are many different types of things you can play with. For example, you have the plus, minus, the multiply and the divide sign. Yes, that's the multiplication and division sign in simplified. And there's also like logical operators too. For example, if you want something to happen, so you can also add an extra condition. So you can say if the score is bigger than 9 and maybe something else, then cause the explosion. So it doesn't really happen only when the score is bigger than 9. You can have or and not, which we will explain in future projects. And there's also these ones called join, letter off, which are more complicated coding structures, which you will learn shortly if you keep following our YouTube sessions. So, so back to the focus of today, variables and if then. So if then, remember, is a condition that helps you separate what different actions should happen for different conditions, right? So when the condition is true, then we run the action. So remember, the condition never runs if it's not true. So for example, just now the underwater adventure, it only goes back to its original position if it touches the octopus, right? As seen in this if then block here. We also took a deeper dive into variables. So you really understood how variables work, hopefully. So you learned how you could store you could store a value for a variable. And one thing to really note is that variables, supposedly they're temporary because when you quit a project, supposedly, so if I open here, and so hypothetically, if I ever reload it, then the score should definitely never appear. But then obviously in Scratch, it has a way of forever storing it for some reason. So this is something that differs between Scratch and maybe other future projects. The variables, they aren't permanent. So the storage only happens when you got the app like started up. But apart from that, they work almost identically. So they can create, we can read values, you can update the values inside, you can delete the whole variable, right? Or you can delete the values in the variable too, or delete the variable as a whole. So that's the way in which they work. So this would actually bring us to the end of our review session today. So if you have any other further questions about about the projects, so for example, if you're looking to really revise on the project, if you want like flashcards, for example, or to help you revise what different type of coding concepts are, or if you want the full project, so if you weren't able to complete it through the YouTube and you want the full project to really understand it yourself, the best way to do this is just contact us, and you can do that through Facebook or through our through our social media or through YouTube. Yeah. So that would bring us for today, the end of our live session today. I hope you guys really just learn about how variables and if then work practically. And remember, these are fundamental coding concepts because they can be applied to practically any coding language you can think of. So as you go into App Inventor, into text-based coding structures or coding languages, these are very important coding concepts that you must know. And so thanks for today. Remember to keep looking through our daily content. So we upload daily every Monday all the way to Fridays. That's 5 videos in a week where you can keep learning and keep upgrading your coding knowledge. So hopefully you guys tune in every day. And I'm Mr. Mark once again, and I hope to see you guys next week or live. I hope you enjoyed the project. Remember to give us a thumbs up if you liked it, and don't forget to hit that subscribe button to keep up with our daily content. I'm Mr. Mark, and this is Scratch Tutorials on Preface Nomad Jr.